Hi everyone, this is Mrs. Lehman from Math with Mrs. Lehman, and I figured I'd do a quick video on something that sounds really difficult, how to find the mean absolute deviation, but really is quite simple. So hopefully I can keep this video short and sweet, but it's a little review of what we did in class today. So the first step to finding the mean absolute deviation, which is a measurement of variability in a data set. So, we have measures of center, mean, median, mode, and then we have measures of variation or variability. So that's a numerical way of describing how spread out our data is. Okay, is it tightly grouped around our one of our measures of center, in this case the mean, or is it really spread out from the mean? So two that we study in 6th grade would be the range. What is the difference between the highest and lowest values of a data set? And then we have the mean absolute deviation, which is how far on average are the values in the data set away from the mean. Okay, so I'll explain that more in a little bit. But the first step is to find the mean of the data set. Okay, so to find the mean, you add up all your values and you divide by the number of numbers in the set. The second step is for each of your data pieces, you subtract the mean from each value and you find the difference. And then, because we're dealing with mean absolute deviation, we need to make sure that the difference is, or the deviation as they call it, is positive. So it's the same concept as absolute value, where we talk about the distance from 0 on a number line. So -5 is still a distance of 5 from 0. So the absolute value of -5 is 5. So absolute values are always positive. Okay, and then the next thing that we have to do is then find the average of all of these deviations. So again, you're finding the average in a way. Again, you're just finding the sum of all the absolute deviations, all those differences that you just found, and then you're going to divide by how many numbers are in the data set. So sounds kind of complicated, but if I go through a few examples with you, I think you'll understand a little bit better. So I came up with two scenarios. The top one is student A, and student A has an average of 80. Now student A has the following grades in the grade book: 80, 80, 80, 78, and 82. So if we look at this on a dot plot, you'll notice that these numbers are all pretty close together here, okay? So you can visually see that there's a low variability with that data set, and our mean, indicated by a triangle, is right there. So this second student, he also, or she, has a mean of 80, an average score of 80, but this kid has some much greater variation in the grades that they've received. So their data set looks like this. Now you can see, looking at the top student, student A, and the example on the bottom of the screen, student B, that student A has less variability than student B. Student B has grades all over the place. Now, the common question is, for which data set or which person or group or whatever scenario is the mean a better indicator of what is typical? So if you have a low MAD, a low variability, that's going to be the data set you want to pick for that. So in this case, student A, the score of 80 is more typical, is more likely to be occurring for that student than it is for student B, whose grades are all over the place. So the mean is a better indicator of what is typical for the student with lower variability. Okay, so let me go through how to find the mean absolute deviation. So the first step you want to do is you look at your mean. In this case, we have a mean of 80, and you're going to look at each of these pieces of data, right? And you're going to find the difference. How far away is that score from our average score? So in this case, 80 minus 80 is 0, right? Another 80 minus 80 is 0. 80 minus 80 is 0, okay? 78 is 2 below the average score of 80, so that would be a -2, but because we're dealing with mean absolute deviations, we're just going to say it's 2 away. And 82 is also 2 away. So what we do next is then add up all of these values, So pretty easy to do. We've got 4 in this case. All right, so we have 4, and we have that out of 1, 2, 3, 4, 5 pieces of data. So then what you do is take 4 divided by 5. You're going to get 0 and 8/10. So we would say that the MAD, the mean absolute deviation, is 8/10. So what does that look like? So I'm going to use a highlighter. Actually, I'm not going to be able to get to that on my screen because the recording bar is over it. But anyway, what that's essentially saying is that, you know, if I were to have this chunked off as a number line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, one more probably. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so I've got that divided up here. So what that's saying is most of our data is going to be 8/10 below 80 and 8/10 above 80. So right in this range right here, most of our data is going to fall. All right. If we look down at this next one, we have some calculations to do. So I'm going to scroll up a little bit. So our average is also 80, but in this case, a kid got a 60. So that 60 was 20 below the mean, so that's a deviation of 20. The second number here, 100, was 20 above the average score of 80. The 50 was 30 below, and then this kid got a 110 with some bonus points, which also is 30 above the average. So we take all of these deviations, the 20, the 20, the 30, and the 30, and we add them together. When you add 20 plus 20, you get 40, plus 30 is 70, plus another 30 is 100. So we have 100, but that was amongst 4 different scores. So our mean absolute deviation, 100 divided by 4, equals 25. So our MAD, in this case, is 25. All right, so again, what that's saying is typically this kid is scoring points that are 25, or getting grades that are 25 points away from this average right here of 80. So, you know, typically they're in, I'm going to make a little rainbow here, they're in this section, right? Somewhere from here to here is where they are typically scoring their points, okay? So that's a much bigger variability, much bigger area than student A, who has just this little tiny section. So they're pretty consistent with getting 80-ish scores, where this other kid is getting a really good score and then a really bad score, and then, you know, it's kind of back and forth. So in this case, again, the data set that has where the mean is a better indicator of what's to be expected or what's typical would definitely be student A, because it has a smaller variability. And you'll see this variability, 8/10, is definitely smaller than the variability down here of this one, which is 25 points away from 80 on average. All right, so your homework tonight was kind of the same thing. They talked about in this lesson the different cities, and we talked about how city A is like not really possible on Earth. City E and F are also very odd that they'd include those, but regardless, if you look, city A has absolutely 0 variability. It's always the same temperature all the time. Its MAD would be 0. You know, and we could go through each of these, but you can kind of tell without a calculation that A is 0, and that the one with the highest variability, and therefore the highest MAD, would be city D right here, because, you know, it's spread out from there to there. So, you know, it's one thing to say, oh, this one's spread out, it's going to have the higher MAD, but we actually need to have people know, or students in this case, know how to calculate it, how to prove it. So we have to prove that with some math, and, you know, that's where mean absolute deviation comes in. So an example that you guys have on your homework, you know, they made a nice chart here, and I didn't erase this, but so the mean for these cities was 63. The average temperature was 63 for city G, for all of them, but city G also had an average of 63. And if the temperature is 53, that means it's 10 below what's typical, right? So we take the absolute value of that, and that's how they got a positive 10. All right, so 57 is 6 below what's typical, and you change that -6 into a positive because it's absolute deviation. And you continue to do that. So you're just finding the difference between that data value and the mean. That's why they're subtracting 63 from all of these. And if you can find the difference between the two numbers, just make sure you write it as a positive here. You're good. You then take this absolute value, or absolute deviation, I should say, column, you add that up, you're going to get 44 divided by 12. And when you do that, you're going to get 3 6/10 repeating, so you would round that to 3 7/10. So the MAD here is 3.7. If I go back to the page before, that means typically the temperatures are within 3.8 degrees of 3.7 degrees of 63, right? And I kind of try to draw that here on this lovely deviation plot thing they made. All right, so I kind of got distracted there. Let's go to your homework, which, they have a bunch of questions, but this lesson summary is pretty much the whole lesson. It's how far away data points are from the mean, absolute deviation. You find that by finding the average of the absolute deviations in the distribution. And then the two key things here, in my opinion, are that if you have a small mean absolute deviation, that means low variability, and a high MAD means high variability. And of course, what you consider a small or large MAD is going to be dependent on your data set, So you've got to look at your numbers and how does that number compare to the numbers, the range and stuff you're dealing with. So anyway, this next question that you guys had for homework, it says, suppose the dot plot on the left, and this is on top actually, shows the number of goals a boys soccer team has scored in 6 games so far, and the dot plot below shows the number of goals a girls soccer team has scored in 6 games so far this season. The mean for both of these teams is 3. So they gave that to you. If they didn't, that'd be easy to calculate. You'd add 0 plus 0 plus 3 plus 3 plus 5 plus 7, divide by 6, and you would get 3. All right, so you would just do it yourself, but right now they gave it to us, so yay. So you can see that this boys team, they're a little less consistent. Sometimes they're not scoring any points, and then other times they're having a really great game and they're scoring like 5 to 7 points, which is crazy. And then you've got the girls team, which is very consistent. They have the same average score for their games, but they are getting scores of 2, 3, and 5, but they're not getting those super low scores like the boys team, and they're not getting really high scores either. So you can see that there's less variability with the girls' goals versus the boys' goals. So the MAD is going to be higher for the boys than it is the girls, because you can see this is more spread out. It's going from 7 to 0, right? Versus the girls, they're only scoring points within this section, right? So before doing any calculations, which dot plot has a larger MAD? That means which one is more spread out in that case. Definitely, again, you look at that, the boys have less consistency, that data is more spread out. And then it says use the tables to find the MAD number of goals for each distribution. Round your calculations to the nearest hundredth. If you flip the page of your module book, they gave you a nice little chart to use. So I'll walk through some of this with you. So again, let's write up here on your chart, the mean for both of these teams was 3. So this is why they're saying if you scored 0 points, that's 3 below what's typical. You typically get 3, and if you scored a 0, that means you're down 3 points from your usual. So that's an absolute deviation of 3. So they really should have written on here, 0 minus 3 equals -3, 0 minus 3 equals -3, and then you return it positive. On this next one, they said if you have 3 goals and you usually get 3 goals, that's a difference of 0. So that deviation from what's mean is 0. I don't know if that made sense. That's what I said. All right, so anyway, you know, sometimes you're going to have to repeat the same info. And then for number 5, or I'm sorry, for this one right here, you have 5 minus 3. Now 5 is 2 above what's typical, so that's a difference of 2, and you write the absolute value. 7 is 4 above what's typical. That's how you get that. Now, your next step is to add these values. You're going to do the same thing for the girls' scores over here on the right, but for now, I'm going to help you through with this boys example. So we have 3 plus 3 is 6, plus 2 is 8, plus 4 is 12. So when we find the sum of our deviations, again, this section right here, we're going to have 12. Now we had 1, 2, 3, 4, 5, 6 pieces of data. So 12 divided by 6 is 2. So we would say that we have a MAD of 2. Right? And again, what that's saying is that the boys typically, I'm going to erase some of these other marks I've made, our mean is 3. That means most of the scores are happening within 2 of that. So you can expect that they're scoring in this area most of the time. All right? With the girls, when you calculate that, you're going to find that their MAD is much smaller because they're a little more predictable and a little more as far as soccer goes, and they're a little more tightly grouped. All right, so part C is the last question that I assigned for homework. You do have to do, you know, all of this in this section, but use the example I gave for the boys team. And then over here, based on the computed MAD values for which distribution is the mean a better indication of a typical value. All right, so remember, if it's tightly grouped, the mean is going to be more typical for that distribution, all right, because you want a small absolute mean absolute deviation for that to work, okay? Hopefully that makes a little more sense. But anyway, thank you for watching. If you haven't subscribed to my channel yet, I'm really trying to hit 200 subscribers by the end of the school year, so I would appreciate that. So give it a thumbs up, give it a like, which is the same thing, and please subscribe. Thanks again for watching. I hope you start to enjoy some of this lovely spring weather. All right, bye.